these are not the properties that 3.3 is talking about, but this is just us talking last week. Last week we talked about all of these properties. The log of 1 base A is always going to be what? 0. Does that make sense? Log of 1 base anything. Is that going to be 0? Why? Why? Why is that the answer? Because 8 to the 0 is 1. Remember we did this last week? 8 to the 0 is 1. It should make sense. Okay. How about this one? Log base A of A will always be 1. Does that make sense? Log of, let's go 6 base 6 equals, is it 1? Would you guys agree?
Yes.
Because 6 to the what?
1.
Is
6.
6. Check, it works. Okay, so these properties, you and I, we talked about them, so I hope you remember these. Okay, the next two properties are called what? Inverse properties. Exponential base A versus logarithmic base A. Those are inverses. Okay, what did we say to do here last week? Oh, by the way, this A right here, guys, this is a little small a, log base A of m. What did we say we could do? Cancel out the bases. Base A, what's the answer? M. M is the answer. Now, how does this make any sense? Well, let's try it. Let's go. Base 10, raise it to log base 10 of 100. Do you know the answer to that?
100.
Why is it 100? How'd you get that?
Cancel out.
Yeah, so Sylvester says I can just cancel the bases out and it's 100. But does it make sense why it works? Because I think that one's confusing. I'm going to just try this. Let me just do this. Can you answer this question? What is the log of 100? Base 10. Is it? It's what?
2.
It's 2. 10 to the second power is 100, so it's 2. And then 10 squared is what?
100.
So now does it kind of make sense? You see why that works? But you don't have to think that hard, because if you see base 10 and you see little base 10 there, cross them out, the answer is what? 100. Now this next one I think is fairly easy for you. It says log base A of A to the R equals R. Once again, base A, cancel it out, you get what? You get R. Check it out. If I did log of 100. Nope, that's not right. I don't want that. Hang on. I want log base 10 of 10, and I put a 3 up here. Does it make sense that I can cancel out those 10s? And the answer is 3.
Yes.
Yeah? Because 10 to what power is going to be what? 10 to the third? It's got to be what? It's got to be 3. 10 to the third equals 10 to the third. But you can do this anytime you see it. The answer is what? Whatever the exponent is. Okay? Does that make sense? You and I did this last week in 3.1 and 3.2. We did this. Okay? So that was not the new part. Here comes the new part. This would be property number 1. Today, when you see the log of any number, but the number inside is multiplication. U times V. You can break that up into what? What does it say you can break it up into?
Addition.
Addition of 2 logs. So you can just say log of U plus log of V base what?
A.
Base A. The bases never change. They don't change. Okay? So here's an example. If you want log of 12, well, 12 is really just what? Log 3 times 4, right? Okay, so you could break that up into log of 3 plus log of 4. And the basis is, what's the base here? Yeah, the base is 10. Doesn't say it, but that's known as the common log.
Wait, how come it was 3 and 4 when it could be like 6 and 2?
It can be. It can be. Yeah, I can change it to 6 and 2 if you want. I mean,
Doesn't matter.
doesn't matter.
Oh.
All I was doing there was just trying to show you how the property is used.
Okay.
It can be 6 and 2. It could be 12 and 1. You know, whatever you want it to be. Okay. All right. How about this one? Log of division. When you have log of a number divided by a number, well, what are we gonna? Whoa, what are we gonna do here? Sorry, something happened here. What are we gonna do? We're gonna change division over to what? Subtraction, right there. So it's log of u minus log of v. The bases stay the same. Here's an example of what could happen. Log of 12 is the same as log of 24 divided by 2. Which equals log of 24 minus log of 2. Bases don't change. So going with what Aomi said what? Why does it have to be 24 divided by 2? It doesn't. Give me another way to write that. Log of 12 could also be what? How else can you get 12 with division? 36 over 3. Okay? So if you saw that, you'd do what? Log of 36 what? Log of 3. Okay? And what if I told you we're in base 3? Base 3, base 3. Do you know the answer to either one of these? Yeah, you know the answer to this, right? In your assignment today, guys, they're not going to leave the answer like that. They're going to keep going. If you know the answer to one of these, then just tell me what the answer is. This one, you don't know this one. 3 to the third is 27. 3 to the fourth is 81. I don't know this one. Leave it like this, but then this one you'd write what? Minus 1. Because 3 to the first is 3. Okay? So that's what they're going to do in your assignment. And you're going to go, why did they do that? Well, because you know the answer. Okay? Expand using the properties we just talked about. Here's a problem you'll get in your assignment today. Log of that. Take that and expand it, which means make it longer. The word expand just give you multiple logs. Log plus log minus log, whatever. So what operation or operations do you see inside?
Multiplication and division.
Multiplication and division, good. When you guys see both multiplication and division, take care of division first, okay? So division's the one you want to take care of right away. So division, you're going to do what to these two? Subtraction, yep. So you're going to go log minus log, okay, and you put the numerator first and the denominator second. So this is log of 3xy minus log of z.
Would be 1, 2.
Now here's the deal. Yeah, base 2, but here's the deal. You're not done unless you have the log of one number plus or minus log of another number. You have a log of 3 times x times y. You have 3 numbers. You can break this up into more. What would you break this into?
Log of 3 plus 2.
Yeah, I was just hoping you'd say addition. Multiplication of numbers. If you're taking a log of a product, turn it into a sum. So you'd say 3 numbers, then I need 3 logs. Log plus log plus log, right? And then of course that minus log in the end, but let's get these down first. Log of what? 3 plus log of x plus log of y. Right? And then of course don't forget your last piece, minus log of what? Log of z. There you go. You good? Okay. Hopefully this rings a bell. You actually did these last year. Here comes your last property, property 3. Property 3 basically says this: if you're taking the log of a number raised to a power, where can the power go? In front. And that's really what this property is telling you. That's it. So look at this one. Log of 5 to the 4th base 6. Well, where's the 4 go? Right in front. So now it's 4 times log of 5 base 6. Okay? All right, what about the next one? Log of 4, or not log, natural log of 4 to the x. Where does the x go? Right in front. Right there. That's it. That's all it is. It's that simple. Okay? On this same slide, will you do this? Let's go like that. And then let's do this. Boy, okay, log. And let's go 10 to the negative 3rd. Will you come up with an answer to this? Using, listen to this, using that property. Okay? Come up with an answer. And you don't need the calculator to come up with an answer. Using the property, where'd you put the 5? In front. I hope you did this. Yep, 5 times log of 10 plus negative 3 log of what? 10. Okay. Well, I did put base 10. I shouldn't have. If I didn't put that 10 there, would you have known it's 10?
Yeah.
Because anything without a base is base 10. Unless it's ln, then it's base e. Okay. So what's the answer to this? Did you get it? Did you get it or not? 2? Negative 2? You got negative 15. Okay. Ready? Let's try it. 5 times what? Log of 10. What is the log of 10? Isn't it 1? Yeah. 10 to what power is 10? First. So it's 5 times, that's 1, plus negative 3 times log of 10, base 10, is 1. So that says what? 5, take away 3, answers what? 2. Okay, guys, last period they said, well, why can't I use that property you showed us right away? When you have a base 10 and a base 10, can't I just do this? And then base 10, can I do this? 5 plus negative 3, the answer is 2. You can do that. The problem is, I said what to you? I said using the property I just showed you, work it out. And so that's why you probably didn't do that, I'm thinking. You just put the 5 out in front, you put the negative 3 out in front, and then you did the work. Okay, next. Again, a little more practice. Would you please expand this one out? Now you know property 3. Property 3, you're going to change it a little bit. Go ahead, do it. Jeff, you guys took the test late. Did I ever show you the test? No? I'll look for it as soon as I'm done here. Oh, okay. Did you just take it on Thursday? Oh, then maybe I probably didn't grade it. Hope you see division in there right away. The second you saw division, did you break it into what? What? Subtraction? Good. Yep, that's what you should do. So it's log minus log. You're taking log of the numerator minus log of the denominator, right? Good? And then when you look at each individual log, you can say, well, what's going on? Between here and here and here, that's all multiplied. So you're going to break this into what? How many logs? 3 logs. What are you going to do to them? You're going to add them. So it's log, it's log plus log plus log, right? Okay, and the first number is 2. Second number is x cubed, which means you're going to put the 3 where? In front. Next one is y. Right? Nothing to do there. Okay, minus this one. Well, you got to understand, this exponent goes where? In front. You get 2 times log of z. That's it. Good. The word was expand. Now, the next one. The next one, it doesn't say this, but I'm going to tell you this right now. Write it as a what? Single log. Another, what the word you probably heard last year in Algebra 2 was condense. Condense it. Make 1 or 2 or 3, sorry, make 2, 3, 4, 5 logs into 1 log. So push it together and make 1 log. When you run into this on your homework, just work with 2 logs at a time. So what would you do with these 2 logs since it's addition? Multiply, right. So log of 3 times what? It's a, but that's your exponent, so this can go up here, right? So it's 3a what? 3a squared. Those 2 make log of 3a squared minus 4 log of b. Okay. Forgot my log. Okay. Now you have log of a number minus log 4 times log of a number. So minus means what? Now we're going back where? What? We saying so. Log of subtraction, 2 logs subtracted, will be log of what? Dividing, yeah. So what's first? Whichever first is your numerator, whichever second is your denominator. By the way, that's b what? That's b to the 4th. This base is what? What is this base? It is 10. I don't have to put it, but I'll put it right now just to show you. It's base 10. Okay? All right. Here is a problem where you have 2 logs set equal to each other. So if this is true, if you have log of u base a equals log of b base a, if your bases are both the same, base a, then what do you know about this number u and this number v? They have to be what? They have to be equal. Exactly. So then knowing that, write the following equation right here. Write this equation without any logs. All the words that say log, get rid of them. So what is this the same as?
Y equals 3 times x.
Y equals what?
3 times
3 times
x.
x. Can I just say 3x? Okay. How'd you do that?
You get rid of the log. You just cross it out, and then.
Oh, did you just look at it and say y equals 3x?
Yeah.
Okay. I would have got it to look like this, log equals log. I would have pushed those two logs together. I would have just said log of y must equal log of what? Isn't that addition? Push them together, make what? Multiplication. Now I have it looking like this. It's base 10, isn't it? So these bases are identical bases. So then I can just say this number must equal this number. But you were supposed to push those two logs together to get one log. Okay? All right. Even though, Naomi, I think you did that. I think you did it in your head. I just trying to show the work that goes with it. Okay, this is a cool one because this we use tomorrow a lot on your assignment and the next day and the next day. So change a base. Now this is kind of neat because there are certain log problems you can't do in your head. You just can't. Like for instance, well, I shouldn't say that because maybe, I'll give you that problem. Maybe some of you could get that answer. Like if I told you to log of 16 base 8, can you do that in your head? What's 8 to the first? 8. What's 8 to the second?
64.
Missed it. Didn't get there. The answer is between what and what though? It's between 1 and 2. So if you can't do that in your head, there's something called change the base. Go ahead, change the base if you want. It says right here, if you have a log of a number of base A and you don't like that base, change it to this. Log of M, right here, over log of your base A, right here. But then you can change the base to what? To what? Any base. You can choose it. You can choose base 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever. Okay? So if I'm looking at this problem, log of 16 base 8, that 8 is way too big. Sorry. Okay, base what? 8. How do I do it? I just change the base. If I don't like it, I'll go like this. Log of what? Log of M base A is the same as log of M over log of A. So what would this one be? Log of 16 over log of 8. There you go. But what's the base? What do you want the base to be? Something that you can handle. Base 10. Now why'd you pick base 10? It's a common log and it's found where? On his calculator. He knew to say base 10 because base 10 is on his calculator. But I'm going to say this. You can't use your calculator. Now what base do?
Base 2.
Why base 2? Base 2 is right. Why base 2?
2 can go into both 8 and 16.
Yeah, well, you should know a power of 2 that gives you 16. You should know a power of 2 that gives you 8. Base 2 is the good base. What is this answer right here? 4. What's this answer? 3. Guess what? The answer is 4/3. That was the answer the whole time. So changing the base is pretty cool. You can change the base. You can just say log of 16 over log of 8 and then pick a base you want. Now, that doesn't always work. Why not? Because sometimes I don't have a good base to pick from. So then I'm going to go with the way Alex said. He said go to base what? 10. Why wouldn't you go to base 10? Base 10 is programmed in your calculator. So is base what? Base E is programmed in your calculator. So look. These are the commonly converted logarithms. Okay? Most people look at a problem like this and when they convert it, they change the base. They change the base to be base what? 10. Now, this is called the common log. It's in your calculus. This one's called ln. This is base E, base E. So most people, when they change the base, they go base 10 or base E, okay? Now, how would we do this problem right here? How can we change the base formula to help us? How do you get that answer? First of all, that says 3 to what power equals 8. That's what it says to you, and I don't think you know. 3 squared is 9. 3 to the third is 27. 3 to the first is 3. It's not happening, guys. So you better change your base. Let's do common log right away. So if I want to do common log, what is it? Somebody read it to me. How are you going to put it? If I want to get the answer, I'm going to change the base. Change it to the common log base 10. How's it read? Uh-oh, you're not seeing this. See that right there, guys? That is this. Log of what? 8 base 3. That's what that is. Change it to the common log. Wouldn't it be log of 8 over log of 3? Exactly. Base 10, base 10. Because it's base 10, use your calculator. That is how you answer that ugly problem. Or you can do what? You can do the natural log. You can do it this way. The natural log of 8 divided by the natural log of 3. Either way you do it, guys, you're going to get the same answer. Punch it in. And don't let the other guy do it. Punch it in. This one's base E, by the way. As long as your bases are the same, it's going to work. What do you got? 1.985. 1.985. Is that what you said?
I got 1.89.
892. 3.
That's what I got.
Okay. I think that's right because I remember doing it in period 4 and 5. Here's the deal. If you don't think you're right, what would you do? Why don't you just check it out? What is 3 raised to the 1.893? Is it 8? Or is it close to 8? Because that's what it's supposed to be. I think it is, right? Right, guys? Yeah, okay. And there you go. That's called change the base. Change the base to the same base and it will work. But why wouldn't you do base 10? Why wouldn't you do base E? It's programming. It's programming your calculator. Do it. Okay. I hope I got the late 3-1, 3-2, the worksheet, all that up here. I'll try to get all that in my grade book tonight. I'm looking for quizzes. If you have questions, you should say some.
We both have questions.
What's your question?
And we don't get out when we
No.
Yeah, you change 3 to 3 squared. Okay. What you have is you have 3 squared. Equals
How?
9. Two bases have to be the same. So here's what I would have done. I would have left that 3. 3 to the
I didn't use my phone.
plus. I would have changed the 9 to 3 squared is 9. You see what I'm saying?
Yeah.
Okay, but you guys did 9, and 9 is okay, but watch this. This is what you would have to do. 9 to the x equals. How do you change the base?
Anything on phone?
9 to 1 here.
No, it's not.
But you guys, you got
That's
base
the
3
only
equals base
phone,
9.
I think, that you can find it.
Yeah. Yeah, not
for-
I see where you're trying to steal.
Oh, what's it?
Yeah.
I think
Okay, so base 10, right? So set them equal to. Ooh, no. You know what? I would have done this. This number, higher exists, must be identical to this.
you didn't find it.
I did.
Where do you want the lines? Oh yeah, that's how it is.
Okay, but the way you wrote it, it's X. You know, how do I know that's X? Equals negative 9, this is minus C1, that's minus X. So what I say is,
Oh yeah, beautiful.
Streets are smooth.
You're moving too fast. Okay, I'm sorry guys, quizzes are in my hand before you leave. If you have questions on your quiz, stay after, I'll talk to you about it, I'll even write you a late excuse for your next class. That's all my quiz. Quiz.
Oh, it's fine.
No quiz.
The only 100%.
Yeah, consistent.
You're Canadian.
Says,
200%.
You're
Canadian.
yeah,
Otherwise.
Which is why it's A.
Because his dialect just needed consistent. Stupid. 8. Really sucks since we live so close to Canada. We oftentimes say 8. Well,
Here's what I keep telling you.
Well, we sound well.
That's the difference between
Eddie, before you leave, I need to touch this. What I do is I'm saying I
That's not me.
can't, well, you know, here, I say, if I can't read it, I can't give out. So I say, letting you know this. I need you to read it, and you get the, here, what I did it. You know what I do? You gotta do it in my class. You know what I do? You know what I do at 12.5? So you got 13. But you're fighting over half a point, but here's the deal. You didn't show your work entirely, and then you didn't give me a number that I could read, so that's why I took half off. But like if that happened again, it'd be another half, and then it would have cost you.
Okay.
So what I'm saying here is, when I read your answer, 1/12, I better be able to read -3, and I do a pretty good job with you because you have. I mean, that can be interpreted in many ways. Who knows what that is? 3. Yeah, it looks like a 3. This one does. But what's that answer right there? Struggling, aren't you? Yeah, -A. I thought it was -4. So you know what I'm saying? You guys got to make sure I can read. You're fighting over it.
Okay.
I get. So,
I was just gonna ask you the properties is it again?
what?
Was it the one property?
Yeah, what?
Was that me again?
Where am I at? Where am I at?
It was for both of them.
Oh, 1-to-1 just means your bases have to be the same. So, Harry, in this problem, well, I can't.
So we just get the.
So what did you do?
What's that line? But I did it wrong.
Oh, I see. It's the wrong one.
I did it wrong. Both.
Right, I'm gonna learn this.
Yeah, right here.
So you Oh,
I
you
was-
did, here's what you
I
did,
did.
this is what you did, you did 3 squared, 9, so now your base is the same, right? No, you don't,
Retake.
you have 3 squared equals 9. And this is raised to the x, and this is raised to the x plus 3, right? Well, guess what, your bases are 9. Yeah, that's 9, yeah, I mean, if that's base 3 and that's base 9, it's not the same.
Really?
What you would have needed is you would have needed this 9 to the 1 half equals 9. Now they're both base 9. Would you say 9 is 1 half base 3? Yeah. See, then you have to do plus 3.
I know, it's weird.
This is x. Then you do 1
I
half.
know, at all.
And that's what I did it 2 instead.
I know, but when you wrote that 2, you said 3 squared equals 9 to the first. Yeah, but the one-to-one base says that your bases have to be identical.
I get it.
And that's what that's I mean, that's base 10.
No,
Yeah.
I was like,
You said 1. Okay,
this one.
so now this.
I did that, I did the same thing. I'm pretty sure I did the exact same.
You got 1/3
I guess.
to the base. And then here you did. To the, well, that one should work. Because you have 1/3 equals 1/3.
But I probably did something.
Wait, 1/3. You did a negative 3. That is 27. That should work. And then this one is 1/3 of what? So 1/3, 1/3 should work. There's nothing to do other than set this.
Yeah. Oh, I put a 5 instead of 8.
It's so embarrassing.
No.
Yeah, I know.
Yeah.
So then you said
Yeah,
it.
I should have been 8. I was just,
The only thing I can say to that is you could have shifted one.
come on.
Well, you got a calculator, I mean,
Where did it say don't use a calculator? Let's all say don't use a calculator.
yeah, this wasn't.
Yeah.
The whole thing was supposed to be, but, yeah, but I mean, and you're like 8 times what? Minus 1.
Yeah.
Yes.
So that'd be negative 16
They're
fifths
stupid.
minus 1. That's negative 3 and a fifth minus 1 is negative 4 and a fifth. I don't think that
He's
equals.
smart, he's actually a smart one.
I mean, you can
Yeah, I think it's just.
But anyways, silly mistake, right?
Yeah.
Okay.
Yeah.
Yep,
So,
that'd be my fault, actually. That would be my fault.
It's a big yellow stuff.
Yeah. It's just the truth. I tell him that all the time. Like, I'm
See ya.
being straight up.
Oh, I'll see you later for sure.
all right, Lauren, you're doing a retake. You have a question I'm supposed to be asking Gabby.
I have a quiz.
Oh, you have the quiz, yes. Well, Gabby, there's about 4 of you that have to take that quiz. There you go. There, yep. Okay. I was just reading something to make sure
Oh,
I didn't have to tell you. Number 1,
Yeah.
be careful, like when you draw your parent, I mean, then look at your parent and do the transformations. And I'm looking for like 2 good points,
Okay.
maybe where the asymptote is when you're all done.
Oh, where the asymptote is.
Yeah, like your parent asymptote, it might change.
Right, that's what
Because you might go right, left, up, down, you know what I'm saying?
Yeah.
And now, Lauren, do we want to look at the old test?
Yeah.
That's the old test. Here's the new test.
Can I ask you a question?
Yep. Yep. She's gonna look at her test for a minute or 2, right?
And then I have a question.
But here's the new one, I'll just put that here. Okay, what do you got?
I'm confused on graphing.
weren't you gonna ask him a question more?
No, it's fine.
Well, she's reading.
I'm gonna
her-
look over this first.
Hey, Lauren, make sure you look at all the ones you got right. Because the ones you got right, you haven't practiced any of them. Okay.
No, I don't get how to graph 39. That's two.
Oh, okay. Well, first of all, no, I like this. We get parent right there. That's 1, 0, and then the base is 3, so it's 3, 1. Okay. And that's the parent every time. Now, to me, is this not in parentheses? Okay, so then the +2 in the back is
Up to,
up to.
and then it's over the Y, right?
No,
Oh,
no, it would be over the Y. This is over the Y. This is over the Y.
oh, okay. that
This is over when it's out in parentheses. Okay, and that's why you're getting it wrong. So now, what's first though?
Reflect.
Mm-hmm. Then
And then it would be.
I got a little lost on this one. How did you do that? Because when you reflect over Y or X, this point doesn't. It's on X.
Oh.
You get what I'm saying? You can't,
Yeah.
if you're on the x-axis, you can't reflect over it. Then you lift it up 2. I don't know where 2 is. This 2 up here?
Yeah.
Oh, this is 2. So up 2 would get you here. If you reflect this over the x, this is up 1. So now we're down 1.
Yeah.
And then now lift it up 2.
But this one doesn't move at all?
No, this one moved. It went up here. Watch this. That's reflected. Hang on. That's reflected over x. It doesn't reflect.
Oh, okay.
And lift it up 2. 2. This one gets
It's right
reflected
here,
over
so it's
and then up
1, 2.
2 back on the same spot. You're
Okay.
on the same spot. Now, if you're confused on what it does, it keeps going, right?
Mhm.
Eventually, we're going to be at 2 somewhere, right?
Yeah.
Okay, so now I reflected it down 2, lifted up 2. Now here's where you're at. So
No. Lost.
Oh, got lost? Okay. What I'm saying is your parent comes up and it hits 1, 3, 1. At some time, it's going to hit 2, isn't it?
Yeah.
Okay, when it hits 2, if I reflect 2, I'm down 2, and then I lift it up 2, boom, boom, I'm right here. So I've got this point, I've got this point, I've got this point. So what I'm saying is as I go this way, it's going to go down forever. Because this is going up forever. This one's going to go down forever. Because it's a reflection over X. Then the problem becomes, what about this old vertical asymptote? What happens? Well, did you ever move right or left? No. So if you don't move right or left, how can a vertical move? I mean, if you move the vertical asymptote up 2, I mean, really think about it. Here's a point on the vertical. If you reflect over X, you're up here, and then you move it up 2. Big deal. You're still here, right?
Mhm.
You're just going to go straight up the y-axis, right?
Okay.
Okay. So your vertical asymptote does not change. The only thing that would make that thing change is a right or a left movement. Yes?
So then,
We're done.
if I just guess where my x-intercept would be?
Oh, they want the x?
Yeah.
Oh, okay. No, you can't guess. I'm sorry. When you can't see it or understand what it is, then you have to say, well, I'm going to set my equation equal to 0. Because that's, your x-intercept will always be 0 for y. So let y be 0. And now solve that equation.
Okay.
It's negative log of x plus 2. Just write that up. Negative log of x.
Of X,
Well,
not 3X?
Well, it's log of x base 3 plus 2. Now, when you solve log equations, you're going to learn this tomorrow, I think, or maybe Wednesday. What do we have to do? Get log of x by itself. So this 2 comes over. And then Now you want log of x. You don't want negative, so get rid of the negative 1. Okay, so the answer is right there. That's your answer, x. But this is a log problem. How do we understand this better? Exponentially.
So it's
3
3
to the second equals x. So guess where you're crossing? It's 9, 0.
How did I expect us to solve it like that when we did it on last one?
Well, but you can look at this and say, I did it, first of all, I did it 2 or 3 times in your notes. But I said every time you want the x-intercept, if you can't see it, you don't understand where is it, then just always remember y is 0. So if it's 0 here, then get log of x all by itself. And I did this probably 2 or 3 times. Sometimes it's really easy because you can see it's just, oh, move your x-intercept over 2. There it is. But sometimes it's not. And when it's not easy, set it equals 0. Anyways, that's it. You got it right. The answer's 9.
Okay.
So 9, 0. Good? Yes, ma'am. Did you come in late today? Today? You came in late? I know you were here today, but I don't even remember marking you absent. Really? Okay. Sorry. Hang on, let me change it. Okay, so that's not it, that's not it, that's, nope, okay.